Good morning. Logarithmic inequalities. When we think about logarithmic inequalities, there are a few rules to be remembered. Okay, let us see those rules. A raised to x greater than a raised to y. Suppose if you have a concept like this, a raised to x greater than a raised to y, that implies x greater than y if a is bigger than 1. And it is x less than y if a is smaller than 1. Like for example, if you have a question 2 raised to x greater than 2 raised to y. So when you consider this question, here the base 2, which is instead of a, it is greater than 1. A is greater than 1, like that 2 is the base here, it is greater than 1, it's bigger than 1. So we can say its answer as x greater than y. Instead of that, if your question is 0.5 raised to x greater than 0.5 raised to y. When you consider this question, here the base is 0.5 instead of a, and it is smaller than 1. It is smaller than 1. In such case, we get the result as x is less than y. Okay, this is the first rule. Actually, this is not a rule from logarithm. This is a rule from exponents, but it is very much useful for us in logarithm also. Now let's see the second rule. Rule number 2 is log x to the base a greater than log y to the base a. See, these all rules are useful, applicable for common logarithms and natural logarithms. So log x to the base a greater than log y to the base a. It gives us two results based on the base. If the base is greater than 1, then we can say directly x is greater than y. That means directly we can cancel logarithm. Actually, we cannot cancel logarithm. I'll show you why the logarithm is getting cancelled. Okay, in a problem, I'll show you how the logarithm is getting cancelled. Okay, and if the base a is smaller than 1, then we get the result as x is smaller than y. That means if a is smaller than 1, the inequality gets reversed. The inequality gets reversed. Okay, this is law 2. Like if you have a question log x to the base 2 greater than log y to the base 2. When you consider this question, the base is 2, which is greater than 1. So we can say here clearly x is greater than y. Instead of that, if you have 1 by 2, if it is 1 by 2, what happens? This greater than will be changed to less than. Okay. Third law is log x to the base a greater than y. That also gives us two answers based on a. If a greater than 1 and a less than 1. Based on these answers, we get two results here based on the value of a. So if a greater than 1, we get the number x is greater than a raised to y, changing into exponential form, that's it. And if a is smaller than 1, we get x is smaller than a raised to y. Okay, and in addition to these all laws, in every logarithmic inequalities, we have to find out a very important term that is known as domain. Domain value of the logarithm must be found out. Let's discuss how to find the domain. Consider a question. Solve log 2x plus 3 to the base 2 is greater than or is equal to 5. Okay, in this case, there are two parts to be done. One part is to find the domain and the other part is solution based on the base. Okay, like let's make two parts here. One part is based on this base. As the base is 2 greater than 1, as the base is greater than 1, we can say 2x plus 3 is greater than or equal to 2x plus 3 is greater than or equal to 2 raised to 5, isn't it? That gives us the answer 2x plus 3 greater than or equal to 32. Now do the normal calculation, like if you subtract minus 3 on both sides, we get 2x greater than or equal to 29. If you divide both sides by 2, we get x greater than or equal to 29 by 2. That is x greater than or equal to 14.5. This is the normal result. Now, in addition to this, we need to calculate a term known as domain. But we have to calculate domain of the logarithm. To calculate domain of the logarithm, you have to take this expression. This is an unknown expression, isn't it? Log 2x plus 3 to the base 2 greater than or equal to 5. In right side you have 5. 5 is a known term. You know the value of 5. But we do not know the value of 2x plus 3. It is an unknown expression. So take this expression. Okay. And as you know, logarithm, when you deal with logarithm, the number must be positive. Logarithm cannot be taken for negative numbers. So here we can take a concept that 2x plus 3 greater than 0. 2x plus 3 greater than 0. This is the additional concept we have to use in every logarithmic inequality solutions. Okay, from this we get, if you subtract 3 from both sides, we get 2x greater than minus 3. When you divide 2 from both sides, we get x greater than minus 3 by 2. That is x greater than minus 1.5. Okay, so now this is known as domain. That means for this question, the minimum value of x can be taken as negative 1.5. That is meant by this question. It should be greater than negative 1.5. That is the domain value. Domain means you have learned in functions, domain and range. Okay, so now we have to take care of these two values. Now we got two different values for x. Okay, now we have to take the intersection of these two values. Let's see how to find that one. Here let's consider the number line. On this number line I marked only these 2 points. One is minus 1.5 and the other is 14.5. So as per our concept, the first result what we got is x greater than or equal to 14.5. X greater than or equal to 14.5. Just I am drawing here. This is a region represents x greater than or equal to 14.5. Is it? Okay. Now let's see x greater than or equal to minus 1.5. Which is that region? Yes, from here to right side. Yes. So this is the region represents x greater than or greater than minus 1.5, and this is the region represents x greater than or equal to 14.5. Now let's see which is the common region of both these lines. Where do you find the common region of both of these lines? Yes, from here now. From here now both the lines you could find. What is the region? X greater than or equal to 14.5. Therefore the solution is x greater than or equal to 14.5. You got how to find this? It's a bit difficult to understand. So let's go for another question. Solve log 2x minus 3 to the base 1 by 2 greater than log x plus 4 to the base 1 by 2. Okay, so let us find the common solution first. Okay, so we have to find here common solution and two domains. Which are the two domains? Domain value for 2x minus 3 and that for x plus 4. So here we get totally 3 values for x. By combining or by taking the intersection of these 3 values, we get the final result. So let us find the first value of x. So when you consider this logarithm, the first and very most thing you need to take care is the base. Here the base is half. That means base is smaller than 1. Base is smaller than 1. As the base is smaller than 1, as per our rule, that sign gets reversed. Inequality gets reversed. As the base is smaller than 1, what happens? The inequality gets reversed, changed. As the inequality is greater than here, it changed to less than. So our first solution is 2x minus 3 less than x plus 4. You have to do this calculation first. Why it is less than? Yeah, as the base is smaller than 1. Okay, now let's solve it. If we add a 3 on both sides, we get 2x less than x plus 7. And what shall we do now? If we subtract one x from both sides, we get x less than 7 as the first solution. Okay, now let's go for the domain values. For domain values, we need to take care that the logarithm of a number is always positive. When you consider logarithm, the number must always positive. So for domain value, the first value is 2x minus 3. The 2x minus 3 must be positive. So for that, add a 3 on both sides. We get 2x greater than 3. If you divide 2 from both sides, we get x greater than 3 by 2, which is x greater than 1.5. Okay, there is this one. Now here we have one more logarithmic value, x plus 4. So in that case also we need to calculate the domain. That is x plus 4 greater than 0. Subtract 4. We get x greater than minus 4. Okay. So now here we got 3 values for x. One is x less than 7, x greater than 1.5 and x greater than minus 4. Now we need to find the intersection of this region. Our solution will be the intersection of these all regions. To find out that, let us draw a number line. So on the number line, I marked all our required resultant values like 1.5, -4 and 7. Okay, now let's show this corresponding region on the number line. X smaller than 7, x is smaller than 7, 7 is here, so x is smaller than 7 represents this part, isn't it? Yes. Okay, now the next region is x greater than 1.5, x is bigger than 1.5, 1.5 is here, x is bigger than 1.5, x is bigger than 1.5 represents this region now. Bigger than 1.5, bigger is always to right side, that's also drawn. Now the third one is x greater than -4, x is bigger than -4, so -4 is here, x is bigger than -4. So you see, we have drawn all the three regions now. Now as per our rule, the solution will be the intersection of all these regions. Solution will be the common region. Which is the part represents common? Yeah, this region now, from here to here. Because here only two lines are there, here also only two lines are there. So this region gives us all the three lines. So this is the region of this question. That means the answer will be x lies between 1.5 and 7. Means you see the x value will be here, x is bigger than 1.5 and smaller than 7. So that will be the answer of this question. Question: solve natural log 2x plus 1 less than or equal to log x plus 4. So this question is dealt with natural logarithm. So as we know, all the rules are applicable for both the logarithms. All the rules what we learned today also applicable here. So let's find the common values first. Okay, and here the base is based on base, we decide whether the sign remains same or inversed. Remember, if the base is greater than 1, sign remains same. If the base is less than 1, sign gets reversed, isn't it? When we consider here, the base is e. The base of a natural logarithm is e, which is approximately 2.718 greater than 1, isn't it? So the sign remains same. Okay, so we get 2x plus 1 less than or equal to x plus 4. Here actually we have a misconcept. It's not a misconcept. We normally say remove logarithm from both sides. Actually this is not a removing logarithm. Actually this is by applying a law. I'll show you how to do that. Log 2x plus 1 less than or equal to log x plus 4. Now to go to the next step of this one, we'll take a base e on both sides. We are taking base e on both sides, a term b on both sides, because the base of the logarithm is e. What is the base of the logarithm? E. And we have learned a rule, x raised to log a to the base x is a. X raised to log a to the base x is a. This log x and x get cancelled. Okay, similar way, e raised to natural log 2x plus 1. In that case, this e and e is same. So this rule is applicable. So the answer becomes 2x plus 1 less than or equal to same thing here also. Actually, this is the process, but we no need to bother about that process. Directly we can go for the answer. Okay, so let's see how to do this one. You know how to do this one. Okay, so I'm going to subtract 1 from both sides. So we get 2x less than or equal to x plus 3. Now I subtract x from both sides. So we get 2x minus x is x less than or equal to 3. So this is the first solution. Now our task is to find out the domain. To find out domain, let's take the first value of logarithm, which is 2x plus 1, which is greater than 0. Okay, so it gives us 2x greater than minus 1 or x greater than minus 1 by 2. That's the answer. See, in a simple way we are getting the answer just by doing the opposite operation. Now let's take the next part, x plus 4 greater than 0. These both are domains. So in such case, we get x greater than minus 4. So here we get 3 different solutions for x. One is x less than or equal to 3. Other one is x greater than minus 1 by 2. And the third one is x greater than minus 4. Now what we need is a common solution. A solution which is the intersection of all these solutions. Let's see how to find that. So on the number line I marked all the values, 3, minus 1 by 2, minus 4. Now let's make its corresponding region on the number line. Okay, this is the easiest solution. You don't need to think about any other things. Okay, in this way you can answer it. First one is x less than or equal to 3. That means x smaller than 3. X is smaller than 3. Next one, x is bigger than minus 1 by 2. X is bigger than minus 1 by 2. X is bigger than minus 1 by 2. And last one is x is bigger than minus 4. X is bigger than minus 4. Now you see which is a common region here. A region where all the 3 lines you can find out. Yeah, it is from here to here, isn't it? This is the region you can find all the 3 lines. So this region gives us the solution. And what will be that region? That is bigger than minus 1 by 2 and less than or equal to 3, because we have less than or equal to 3. Okay, so the solution is x is bigger than minus 1 by 2 and less than or equal to 3 as the solution. Okay, thank you.